Okay. Sometimes they want you to prove this whole theory of calculus and integral calculus. In that, if we've got a function and we're differentiating between a couple of limits, it doesn't matter what the function is. We're going to get a certain area, and then it's about manipulating this function and how the area then changes. So if we've got this thing, so we'll be given conditions like this between 5 and 0, and for both cases, some function, the area of some is 7.5. Another function is 12.5. Now, finally, we'll be asked to prove certain things. So over here, we've got g of x, so it's 12.5 business, equals, except instead of going from 5 to 0, we're going from 0 to 5. So that's what it wants us to find out. So I'm going to put it with respect to dx there. And now, normally if we anti-differentiate, we'll have our g of 0 minus g of 5. Normally this will be the, we'll have 5 minus 0 here. But instead we've got 0 minus 5. So if we have 5 minus 0 and that gives us 12.5, what do you think this is going to give us? Well, this will end up being negative 12.5. Okay, so if we swap these two, the area, or the definite integral becomes the negative of it. Okay, now for the next one, a little bit more complicated. We've got 5 and 0, and it's 3 times f of x plus 2. So what we do, we can break this up. Let me just separate this a little bit. So this we can say we're going from 5 to 0 of 3fx with respect to dx plus 5 and 0 of 2 with respect to dx. From there, we can make it even more simplified even further. We bring this 3 at the front. So we've got a 3, 5, 0, fx dx plus, same deal here, 5 and 0 of 2x. Sorry, not 2x, 2 with respect to dx. Okay, so now we've got that. We know that f of x, if we're differentiating that, we know we're 7.5. So this is 3 times 7.5. Then you're going to say plus, and here we're going to differentiate this. So we're going to get 2x with 5 and 0. So here we've got 22.5 plus, we're going to have 2 times 5. And now we know that we've got a 0 here, so I'm not going to bother with that because our 0 is going to end up being 0. So here we've got 22.5 plus 2 times 5, which is 10, so we end up with 32.5. So that's how we end up going through that. So whatever they give us, we want to make it so that we've just got our f of x over the limits they set for us. So we do that by removing the new constants, or putting a constant under a separate derivative, and then also if we're multiplying, we take our multiply out the front and it works that way.